Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, most merciful. Dear students, I am Dr. Asrar Ahmad and it's my lecture number 11. This lecture number 11 is related with the second order reaction. This subject is CHEM 4146. Dear students, in my previous lecture, we derived a rate kinetic expression for the first order reaction opposed by first order reaction. But today, we will study in detail the kinetics of a second order opposed by first order reaction. So, in this type of reaction, forward reaction will be of second order and the backward reaction will be of the first order. Due to this reason, this is called second order reaction opposed by first order reaction. To understand such type of reactions, we suppose that we have two reactants A and B and the product is the C. If you remember in my previous lecture, the reactant was A and the product was B and C. But the situation here is different from the previous one. So, we further suppose that when the time was 0 second, then we have reactant, for reactant A we have A mole and for B reactant we have also A mole. When the reaction started, time was 0 second. At that time, reactants were present while product was not formed. So the concentration of product at 0 time will be equal to 0 mole. But when this reaction started after few seconds, this reaction took place and after time t seconds, some concentration of product C has been produced. Suppose this concentration of the product is the X mole. Definitely, the remaining amount of A after time t will be A minus X and the concentration of B after time t second will be also A minus X. Dear students, here the interesting point is that rate of forward reaction will depend upon the concentration of reactant, while the rate of backward reaction will depend upon the concentration of product. Therefore, for this type of reaction, we will calculate both rates separately. First, we will determine the rate of forward reaction, then we will find out the rate of backward reaction, and then we will divide both these rates and ultimately we will get a rate constant expression for the equilibrium state. So, first of all, we will determine the rate of forward reaction. That is directly proportional to concentration of A and B. Since the concentration of reactant A is A minus X and the concentration of B is A minus X. So, according to equation number 1, rate of forward reaction will be equal to rate constant Kf into A minus Xk. In this equation number 1, Rf is the rate of formation of product, rate of forward reaction, and Kf is the rate constant for the forward reaction, and A is the initial concentration of reactant A, and minus X mean the decrease in the concentration. So A minus X mean the concentration of both A and B after time t second. Dear students, similarly, if we find the rate of backward reaction, then it will be directly proportional to concentration of C, and C concentration is equal to X. So rate of backward reaction will be directly proportional to X. If we want to eliminate this proportionality, we have to take a constant. and the rate constant here will be Kb. So according to equation number 2, rate of backward reaction will be equal to product of the rate constant for the backward reaction into concentration of the product. Dear students, we have obtained equation number 1 and equation number 2. So now we will find out the net rate of reaction. To find out the net rate of reaction, we will divide dx over dt as following, and this will be equal to difference of the rate of forward reaction and rate of backward reaction. So if we put the value of Rf and Rb in this equation, then we will get equation number 3. According to equation number 3, dx over dt, rate of the reaction, will be equal to Kf into A minus x square minus Kbx. But there will be a stage of equilibrium. What is stage of equilibrium? It is that state at which the rate of the forward reaction will be equal to rate of reverse or backward reaction. So at this stage, when both rate of the forward and backward, they are equal to each other, then Rf will be equal to Rb. Therefore, X will be equal to Xc, and Xc is called equilibrium concentration. So using equation, here it is some mistake, here it is some mistake. So using equation 3, using equation 1 and 2, we can write the equation Kf into A minus Xc square is equal to Kbxc. Dear students, from this equation we will separate the value of Kb. According to this equation, Kb is equal to Kf into A minus Xc square over Xc. If we put this value back into equation number 3, when we will put this value of Kb in equation number 3, then we will have this equation, this Kb replaced with this value. So put this value of Kb in equation number 3. Equation number 3 will be like this. This portion will be the same, and here we have write the value of Kb, Kf into A minus Xc over Xc into X. So in this equation, Kf is the common term. If we take this Kf as a common term, so inside the square bracket there will be A minus X square minus A minus X square into X divided by Xc. Dear students, here Xe in the denominator, this can be taken as LCM. So if we take the LCM of this equation, that will be equal to Xc. So by taking the least common multiplier, this equation can be written as Kf into Xc into A minus X square minus A minus Xc square into X divided by Xc. The next equation is just very simple because we have applied the algebraic formula A minus X square. The solution will be A square plus X square minus 2ax, and the solution of A minus X square will be A square plus X square minus 2ax. So if we open the square in this equation, it will be like this one. In the next equation, we have multiplied this small bracket values with Xc and this small bracket values with X. When we multiplied Xe with inside the bracket terms, this came to Xe into A square plus Xe into X square minus 2axe into X minus A square X minus Xe square X plus 2axx. Dear students, Here we have taken the common term kf over xc. So in this equation, if we rearrange, then after rearrangement we can say that this plus xe x square and this minus xe x square, they will be cancelled. So the remaining term will be dx over dt is equal to kf over xc into a square into xc minus x minus xex into xc minus x. So this equation has been obtained by simplifying this above equation. Mathematically, we can write this equation as following: a square minus xex into xex. So dx over dt will be equal to kf over xc into a minus a square minus xex into xc minus x. This is the differential rate equation. So for further solution, we will separate the variables in the above equation and then we will integrate it. So by separating the variables and after integration, we get the equation number 4. So this equation became like this one: integral kf and integral dx over a square minus xex into xe minus x is equal to kf xe integral dt, because kf over xe is the constant term, so it cannot be integrated according to rules of integration. Dear students, this equation number 4 will be solved by using partial fractional method. So if we apply partial fractional method to the right hand side of equation number 4, it can be written as 1 over a square minus xex into xe minus x is equal to a over a square minus xex plus b over xe minus x. This is the equation number 5. Dear students, to further solve it, we will multiply both sides by a square minus xex into xe minus x. So when we multiplied equation 5 with this denominator, here will remain only 1. So it is the 1, and the right hand side will become a into xe minus x plus b into a square minus xex. Dear students, now, just like our previous lecture, we will find out the value of a and b. After finding the value of a and b, we will put these values back into this equation and will solve. After solving this equation, we will be able to find the value of kf and kp. So, if we apply the term inside this bracket, that xe minus x is equal to 0. So if xe minus x is equal to 0, it means x is equal to xe. If we put this value in equation number 6, so this equation can be written as 1 is equal to a plus b into a square minus x square, because this x has been replaced with xe. It will be 0, so a will be 0. So 1 will be equal to b into a square minus x square, and the b will be equal to 1 over a square minus x square according to equation number 7. So if we further suppose that a square minus xex is equal to 0, it means x will be equal to a square over xe. And if we put this value in equation number 6, then it can be written as 1 is equal to a into xe minus a square over xe plus b into 0. If we solve this equation by taking the LCM of this equation, then 1 will be equal to a into x square minus a square over xe. So this equation can be written by following as it is. If we take this value from denominator into numerator and the upper value in the denominator, then we will put here minus. Here is minus written here, but in this equation you are unable to see. I think it is missing here. Please insert here minus here at this point, because equation editor is not working properly due to which I am feeling difficulty to write here minus. So dear students, you please write here minus. So a will be equal to minus xe over a square minus x square. This is the equation number 8. Dear students, now he will put the values of a and b from equation number 7 and 8, and we will put these values into equation number 5. When we write these values in equation number 5, then equation number 5 became 1 over a square minus xex into xe minus x. It is equal to minus xe over a square minus x square into a square minus xex plus 1 over a square minus x square into xe minus x. So if you compare this equation with equation number 5, you will note that only the values of the a and b have been inserted in this equation number 5. Dear students, if we further simplify it, then you can see here some term can be taken as common, and that is the 1 over a square minus x square. 1 over a square minus x square is the common term. So we take it outside the square bracket, and the values inside the bracket are minus x over a square minus xex plus 1 over xe minus x. Dear students, now we will integrate this equation. So if we integrate this equation, then applying the integral values before dx, before minus xe over a square minus xex, and before dx over xe minus x, this equation number 4 can be written as 1 over a square minus x square, this one, into integral minus xe over a square minus xex into dx plus integral dx over xe minus x is equal to this kf over xc into integral t, because we have taken this side of the equation with the equation number 4, because equation number 4 here was this value dx over a square minus x square into xe minus x. So we compared this value with equation number 4, and after comparing we got this equation. When we apply the rules of integration, then this value will be written as log natural a square minus xex, and this value will be written as minus log natural into xe minus x. And here we will take a constant, that is integration constant. And according to rules of integration, this equation can be written as 1 over a square minus x square into log natural into a square minus xex minus log natural into xe minus x is equal to kf over x into t plus c. C is the integration constant. Again we will apply the rule of logarithm. So this positive value will be in the numerator and xc minus x will be in the denominator. So this equation number 9 will be written as following by applying the rules of logarithm here. 1 over a square minus x square into log natural into a square minus xex divided by xe minus x is equal to kft over xe plus integration constant. Dear students, just like our previous lectures, now we will find out the value of c by putting the initial value when t was equal to 0, then x was equal to 0. So he will get the value of c, and we will put back this value of c in equation number 9. So if we apply the initial condition t is equal to 0, x is equal to 0, so this equation will be written as c is equal to 1 over a square minus x square into log natural a square over xc. So if we write this value of c back into this equation number 9 at this place, then equation number 9 can be written as following. According to this equation, the right hand side of this equation is the same, and left hand side is the same, and right hand side has been replaced with the value of c. Dear students, here the value of c is positive. If we take this positive value on the right hand side, then it will become negative. So according to simple mathematical rules, this KAFT over XC will be equal to right hand side minus value of c. This is value of c. So again applying the rules of logarithm. By applying the rules of logarithm, this log natural values can be written as following: 1 over a square minus x square into log natural a square minus xex divided by xc minus x minus log natural a square xc. So they will be multiplied like this way in the form of equation number 10: log natural xe into a square minus xex divided by a square into xc minus x is equal to kf into a square minus x square over xc into t. This equation number 10 is the integrated rate equation for the opposing reaction of the type when second order reaction is opposed by first order reaction. Dear students, we can draw following results from this equation number 10. Very simple. Number 1, this is the equation of straight line that passes through the origin. And in this equation, log natural xc into a square minus xcx over a square into xc minus x is the dependent variable, while time is the independent variable. Similarly, if we plot a graph along y-axis, we take this log natural value, and along x-axis we take the time, then we will get a straight line. And the slope of this straight line will be equal to kf into a square minus x square over xc. And from this slope, we can find the value of kf. Just by putting the value of slope from the graph, it will be multiplied with the equilibrium concentration divided by a square minus x square. We will get the value of kf. Kf means rate constant for the forward reaction. So up to here, we have find a relation by using which we can find the value of kf, and remember the unit of kf will be equal to decimeter cube per mole per second. Dear students, similarly, we will be we can we can find the value of kb. How? Because Rf is equal to Rb, x is equal to xc. So again, kf into a minus x square is equal to 2 and kb is equal to kbxc. And kf will be equal to kbxc over a minus x square. So we will put this value of kf back into equation number 10. If we put this value, then we can find that log natural x into a square minus xx divided by a square into xc minus x is equal to kbxc into a square minus xc over xc into a minus x square into t. So when we will simplify and simplify this equation, then we will get the equation number 11. According to equation number 11, log natural xc into a square minus xcx divided by a square into xe minus x is equal to kb into a plus xc divided by a minus xc, because this a plus xc will be cancelled out with the remaining term. This a minus xc will be cancelled out with this. So here will be a plus xc divided by a minus xc. Just cut these values. Dear students, again this is the integrated rate equation. So again the same results. Equation of straight line passing through the origin. Log natural values are dependent and time is independent, and the slope will be equal to kb into a plus xc over a minus xc, and kb will be equal to slope into a minus xc over a plus xc. Dear students, this slope value will be obtained by using the graph. So if we have the value of slope from the graph, it will be multiplied with a minus xc and divided by a plus xc. we can get the value of kb, and the unit of kb will be per second. Dear students, now we have two different values. From equation 11a, we have kf value. Equation 11b, we have kb value. So we will divide equation 11a with 11b. So if we divide the equation, the values of kf over kb, then they can be written as following in the mathematical form. So when you will divide kf with kb, it will be equal to xc over a square minus xc square into t log natural xc into a square minus xcx over a square into xc minus x into a plus xct over a minus xc minus 1 over xc into a square minus xcx. ये log natural भी साथ आएगा a square into xc minus x. This kf over kb, this ratio is called equilibrium constant. It is called equilibrium constant. So equilibrium constant will be equal to xc into a plus xc over a minus xc into a plus xc into a minus xc. It is equal to xc over a minus xc square. Dear students, this equation has been obtained by simplifying the above equation. So here you can find that equilibrium constant is equal to xe over a minus xe square, and the same value you can also find by direct equalizing the values of Rf with Rp. So Rf and Rb, when they are equal to each other, so Kf into A minus Xc square is equal to Kbxc. By just dividing Kf with Kb, you will get the value of Xc over A minus Xc square, and this ratio is same as you have found by using the kinetics of the reaction. Therefore, this equilibrium constant will be equal to xc over a minus xc. So if any student wants to know that if a second order reaction is opposed by first order reaction, then how can we find the equilibrium constant? Dear students, that can be obtained just by dividing the equilibrium concentration with the square of a minus xe value. Thank you very much. Take care of yourself. Allah Hafiz.